All right, so now we're going to take the p-value approach to this same example that we did earlier. Now let's notice in this example, we failed to reject the null hypothesis. That's going to still be the case with our p-value. All right, we're just going to do it by that other means. Okay, now, if we were doing all of this again, all of this would be the same, except when we got to getting our critical value. We would not need to do this when we're using a p-value. We would instead just do our z. We get 1.542. So now let's take our 1.542 and let's look up the p-value. Now let's realize that this is a two-tailed test. 1.542 is on the right of the mean, and we're going to be looking at the right tail here. So what we're going to look up on our table is going to give us the area to the left, or the probability to the left of 1.542. Let's take that 1.542 and put it into 1.542 into our normal distribution calculator. I'm going to take this out from our previous example, and I'll hit calculate, and it tells us 0.938. Now we want to subtract that from 1 because that's the area to the left of 1.542. All right, so our p-value. All right, and I'm going to put this 2 here in a minute. I'll explain what that's for. 1 minus, and I've lost it, 0.938. 0.938. All right, so that's going to end up giving us, let's see, 1 minus 0.938 is 0.062. Okay, now why is the 2 there? The 2 is there because we need to double this value because it's a two-tailed test. So our p-value is really twice this. It's 0.124. Okay. However, even 0.062 is going to be bigger than our 0.05. Now, if we had considered it as 0.10, notice the original alpha that we started with, by doubling it, we're seeing that that p-value is still larger than 0.10, and therefore we still fail to reject the null hypothesis. Here, we wouldn't have to change any of our writing. We still failed to reject the null hypothesis. There's not sufficient evidence to reject the null hypothesis. It appears that economic conditions do not affect the proportion of male newborns. Nothing changes with our p-value.